mental math. We have two negatives in this multiplication problem, so the answer is positive 200. The way I do that is I do pretend like that's quarters. If I have 8 quarters, I have $2, or which would be 200 cents. This one, 2.5 times 3, I think of maybe even 25 times 3 is 75 with 1 decimal point. And then 8 minus 4 is 4, so 10 to the 4th. This one, I crossed out the 22 over 5, because if I divide it by 11, 11 goes into 22 2 times, into 5 5 times, so that actually worked. And then I did 5 times 100, which is 500 divided by 2. 5 times 100 divided by 2 is 250. Okay, how we do 2 feet into square inches, feet cubed squared into square inches, you take what you had and multiply it by inches times inches. So there are 12 inches in a foot. You have to do that twice. So it's 2 times 12 times 12. So it's 288 inches squared. Okay. 8 times 2 1/4. 8 times 2 is 16 plus 1/4 of 8, which is 2. 16 plus 2 is 18. 10% less than 60. Well, 10% of 60 is 6. Take that away from 60 and we get 54. Okay. Another way you could do that is 90% of 60, but 10% is easier to find and take it off by just moving a decimal. Okay, now we're going to do 2-step equations. I love these. And so I want you to be very careful and do them exactly the way I write them, okay? This is one where I really want you to copy everything the exact same way as I do. So we are showing steps. Before we were doing problems like 2x equals 35. That was a 1-step solving line by line, okay? Now we're adding a 2nd step. And the way I decide, okay, so I want this x, really, x wants to be all by itself. So by the end, we know we're good when we have x equals something. Okay, so what we have to do is systematically get rid of everybody over here on this side of the equal sign that's hanging out with x. And we start with we start with the numbers that x has got less of a bond with. So before we take care of this 2, we're going to take care of the 5 first. So we always do, it's like the opposite of order of operations. We're going to do adding and subtracting first to unpack this. So if we want to get rid of this 5 on this side of the equal sign, then what we need to do is subtract it, right? Or do add minus 5, right? But in order to make that legal, we add minus 5 to the other side. And you see how I wrote minus 5 under each and drew a line. Please do it that way, okay? So now we can vertically find the sum. Well, 2x is still hanging out, equals, and we have 35, positive 35 and a negative 35, or 35 minus 5. The same answer, it's 30. Okay, so now we're on something you saw before. We have 2x equals 30. We want to get x alone, so that means 2 times x. So kind of undo that. We undo that bond by dividing. Okay, and we actually draw the division. Notice that the line was here like a real subtraction or addition problem here. Here we actually draw it because we're kind of making it look into a fraction because we're dividing. Okay, so that worked. We do have x alone now. And when we calculate 30 over 2, we get 15. And we have solved for x. We have isolated the x. There's lots of ways they say that. We found x. Okay, we found the value for x. There is one value that x can be to make this a true statement. And let's double check. Plug in 15 for x up here. So 2 times 15 plus 5 equals 35. So we get 30 plus 5 equals 35. And yes, so we have solved that correctly. We're going to get the right answer. And the teacher is going to give us full credit on this one because we showed all of this. This needs to look just like that, okay? Especially those of you who don't like to write things the exact way I do. I'm really commanding you to do that. Yes, that's a strong word. I'm commanding you to do that. All right, let's use the same idea on these, on a decimal equation, okay? So just like I did before, we've got two things over here hanging out with x to make x is not alone, so we've got to fix that. So again, we take care of this one first. So if we have plus 1.2, if we add negative 1.2, then these are going to cancel each other out, turn into a 0, right? So we have 0.4x equals, now we have 6, and I'm going to give it a decimal point, and we can just subtract this like we did in elementary school. All right, 10 minus 2, line up those decimals, we get 8, we get 4.8, right? So we're almost there. Now we've got 0.4x, so we've got to get rid of this 0.4x, and you can write it that way. So that goes away and we get x equals. Now we've got a decimal problem here. You can go off to the side and do it, or I don't know if you remember this fraction or this division problem is equivalent to 48 divided by 4. If I move the decimal over to both top and bottom, which is a very legal maneuver. So now we have 48 over 4, and because you know your 12 so well, you know that 48 divided by 4 is 12. And there we didn't have to do any calculating with decimals, which is always freeing and probably preferable to you. Okay, now we've got one with fractions. I'm sure you were hoping that would be next. So same way, we're going to get rid of this minus 1/2 by doing plus 1/2 to both sides. Okay, so you might not like this because these are not the same denominators, which is not nice. So if you want to do 1/3 plus 1/2, you have to give them the same denominators. So I'm going to give them each 6 as the bottom. 3 goes into 6 2 times, 2 times 1. So 1/3 is the same as 2/6, and 1/2 is the same as 3/6. So now we do 2 plus 3 is 5/6. Okay? And now we're almost done. This looks like a problem we had last week. We want to get rid of the negative 2/3. So we multiply, make sure we don't forget that negative, by 3/2 by the reciprocal. And make sure we do the exact same thing on the other side. So that's nice because those all cancel out and give us a 1x or x. And we know this answer is going to be negative because we got one negative in that multiplication problem, right? And now I see that I can do a little bit of cross canceling. And so now I have 5 times 1 is 5/4. Negative 5/4. And we can leave it like that. You don't need to write negative 1 and 1/4. And there we go. All right, example 3, same thing. Just it's on this side, which is the same as what we've been doing. So we want to get rid of the 6 first. A lot of people try and do this first. Don't, okay? Get rid of this, the sum first. So we got minus 6 and minus 6, leaving us with just a 3x on the right-hand side. Now these both are negative, all right? So the answer is going to be negative, and we figure out what 15 plus 6 is. So 15 plus 6 is 21. And now we want to get x alone, so divide both sides by 3. Divide by 3. And we get negative 7 equals x. And that is allowed. Now all of these we could go back and check our work. All right, number 4 is different. Now we're talking about inequalities, okay? However, they are solved the exact same way, almost, as when we solve equations, okay? An inequality is solved almost, has the exact same rules, and I think we're going to only use the exact same rules today, and we'll talk about the exception later. Okay, so again, we want to get x by itself, so we're going to add 5 to both sides, keeping this symbol, okay? So if we add 5 to both sides, now we got 2x equals 6, or sorry, 2x is greater than or equal to 6. And then we want to get x alone, so we divide both sides by 2. So now we have x equals greater, or x is greater than or equal to 3. And what it says here is graph its solution. So don't get that wrong on a test by not completing the question. So it says graph its solution. So we're going to do a number line, and we're graphing x is greater than or equal to 3. So I might find 3 on my number line. There it is. Okay, and I see it's greater than or equal to, so that's inclusive. That means it's a solid dot, a solid circle right at 3. Okay, and we're talking about things greater than or equal to 3. Greater than 3 is to the right of it. So there we have it graphed. Okay, so just to recap, this is really saying what are the values for x? What could we make x in order for this to be a true statement? So there is more than one value of x to make it true, because it just needs to be greater than or equal to 1. So when x is 3, this thing equals 1, because 2 times 3 is 6, minus 5 is 1. 1 does equal 1, and that's true. So we also find out that 4 will make this a true statement, the number 4, because you would have 8 minus 5 is 3, 3 is greater than 1. So anything bigger than 3 or bigger will make this statement true, okay? And this is the graph of that. Okay, oh, that was it for the examples. I guess we're going to jump into the practice. So go ahead and turn off the video and make sure you do these line by line the way I just taught you. Okay. So here I will go. I will try and cruise through these faster than I did in the examples, okay? So I add 15 to both sides, and now I'm left with 8x equals 185 plus 15 is 200, divided by 8, divided by 8, so we get x equals, think again about, there are actually 8 quarters and $2, so I know this is 25. Okay? This one, I want to get rid of the negative 1, or get rid of the 1.5. So now I have 0.2y equals, and this is subtraction, vertical subtraction. Line up the decimals, so now I get 2.2. Divide by 0.2. And we get y equals, that's the same as 22 over 2. So y equals 11. Like I said, I'm going to cruise through these pretty fast. Okay, add 1/3 to both sides, and so we get 3/4 m, and in order to do this, that's 3/6, and this is 2/6, and so that equals 5/6. Now we multiply by the reciprocal, 4/3, 4/3. Okay, I'm about to be interrupted, so we have cross cancel, 10/9. Okay, so this one, what we learned last week is let's get these into improper fractions. I think it will save us some time down the road, because, well, it just will. So let's go ahead. That is the same as 3/2 n plus 7/2 equals 14. So that wasn't too painful, was it? So now we're going to subtract 7/2 from both sides. Now, 14 minus 7/2, not very fun, but that's okay, because this is a whole number. So we could say 14 is the same as 13. No, I don't want to do that. We want 14 is going to turn into how many halves? Okay, so it's going to be 28 halves. Okay, so 28 minus 7 is 21 halves. So now we have 3/2 n equals 21 halves. Okay, multiply by the reciprocal, both sides. There we go. So n equals, those cancel out, 21 over 3, which is 7. So that was nice. Okay. And now we've got this one, minus 36, minus 36. Okay, be careful on this one, okay? Because a negative 36 and a positive 12 is going to be a negative 12 taken away from 36 is 24, okay? And we got negative 6p. Now we're going to both multiply or divide both sides by negative 6. So we get p equals positive 4. Okay. This one we're going to add 26. Add 26. So we get 4w equals, these are all just the same sign. So we get 64. Divide both sides by 4. And we get, is that 16? Yes. 16 equals w. Okay. Oh, sorry. Did you even see that? 16 equals w. Now we're going to do more. We got a lot of practice, so that's awesome. Minus 15, minus 15. So we get 45. Negative 5/3 m equals 45. Multiplied by negative 3/5 times negative 3/5. And so now we get m equals 1, that goes in there, 9. 9 times negative 3 is negative 27. Okay. There we go. And you can mentally check this, right? If I put a negative 27 in here, this is going to be a positive. 27 divided by 3 is 9. 9 times 5 is 45. So this is positive 45, positive 15. Yes, that makes 60. Okay, so now we've got this one. Add 6.3 to both sides. So we get 0.6d and we get 10.8. Okay, divide both sides by 0.6. And that is the same as 108 over 6, right? So if you get stuck to, I don't know how many times 108 or 6 goes into 108, you could also cut them in half. That's the same as 54 divided by 3, right? And, or just, you could do it mentally, or you could go off to the side and go, okay, that didn't hurt too much, 18. So 18 equals D. Okay, now we have inequalities. Make sure we see that we need to graph their solutions, okay? So subtract 5 from both sides. So we get 2x greater than or equal to a negative 5 and a positive 1 is a negative 4. So be careful on those. Divide by 2, divide by 2. So now we get x is greater than or equal to negative 2. And now we graph it. Okay, so I might go 0, 1. Doesn't have to be perfect. So greater than or equal to, so it's going to be a solid circle at negative 2. And we are talking about all the things greater than this number. So greater means to this side of the number line, okay, and higher. That's greater than. Greater goes right, okay. This one, add 5, and now we got 2x is greater than 6. Divided by 2, x is greater than 3. So this does not have the inclusive symbol. It is going to be an open circle, and it's going to be at positive 3. Open circle, and we're talking about things less than 3. So less than means down here. And there is our graph. Okay, that is it. Hope you had fun with this. I sure did, and see you on the next lesson.